Hey Defenders, welcome back. In this video, I want to show you guys how we can install our own Malware Sandbox that we host ourselves. The tool itself is called Cuckoo, which is an open source tool that we can use to spin up a sandbox and is what we'll use to run malware inside of. And what this allows us to do is to run malware within an isolated environment so that the malware cannot escape and infect hosts, legitimate host on our network, but will execute the malware within a isolated environment that's running a version of Windows. And what this will allow us to do is to see exactly what the malware is doing, what network activity is going on the box. This will give us full insight into what the malware is doing and give us a safe way to see, okay, is this executable binary, maybe domain? Is this in fact related to any malicious activity? And this will give us enough details to make the assessment as to, okay, is this something that's malicious and we need to investigate further, or is this potentially a false positive? So again, a few key points on why sandbox environments are really nice to have. We can run malware within an isolated environment, and that'll become more clear as we get into it. It'll also give you insight into how the malware is executing, what network connections is it making, what binaries maybe is it trying to hijack. And we're also able to replicate various operating systems and installed software. In this video, we're just going to target a Windows 7 server, but you could also do the same with any type of Linux box to install Internet Explorer 11, some outdated Java. So we're able to replicate what appears to be a legitimate server. However, in fact, it's only running within our isolated environment, and we're able to create those and tear those down whenever we want to run an assessment. And so a very kind of high level picture. Oh, sorry, this kind of got cut off, but this says sandboxed server, but a very high level diagram of kind of what's going on. So we're going to spin up a host server. So this will be a VM that I'll spin up within my ESX environment. And this host server, we're going to install VirtualBox on it as well. It'll be a headless version of VirtualBox. So this VM image that I'm going to use is a server ISO. It's not a desktop ISO, so there won't be any desktop GUI. And we will install the headless version of VirtualBox. And so we're going to talk about abstraction to the next level, but we're going to basically spin up a VM, which will be our host server, and then within that VM we're going to spin up our sandboxed environment. We're going to spin up another VM within that VM to run our malware, and that'll become a lot more clear as we go through it. And again, the networking will be isolated even from the host server itself. We're going to use IP tables rules to do that, so that'll become more clear as we jump into it. But first, let's go ahead and spin up this host server. So again, I mentioned I am using ESX to spin up a VM. So what I'm actually going to do, and if you're actually following along, this is an important step. We need to tell our CPU to give this VM virtualization access, which will just be a quick and easy checkbox, so that'll become clear here in a sec. I am going to use an Ubuntu 18.0.4 ISO which will be our underlying operating system, so our host server here. And I'll give it a 4-core CPU. And so the checkbox that you want to make sure that you check off on, or else the virtualization will not work. So VirtualBox will not work if you exclude this step. We need to expose the hardware-assisted virtualization to the guest OS. So this will allow our VM to spin up, to use virtualization to spin up our sandbox VM within VirtualBox. And all right, so I got the host VM stood up and ready to go. And now let's go through the installation process. I'll link to Cuckoo's install docs in the documentation. I've also parsed out all of the commands that we're going to be running to make this work within the GitHub. So I'll also link to that as well if you want to follow along. Again, I'm going to be installing on an Ubuntu box, so I'm going to select that. And here we'll see our list of commands. And again, I've parsed these out here, so I'll just go ahead and throw this off to the side, and we will follow along. So you could just create a simple bash script if you want that includes all these commands, so you don't have to run them one by one, but I'm just going to go ahead and do it the old-fashioned way. You will also notice I'm not logged in as the root user. I just created a basic user account that does have sudo ability, so that I'll be able to install everything that we're looking to install. And we will run Cuckoo as this user. We don't want to run it as a root user. That's just not best practice, especially with a sandbox environment where we will be working with malware. So we're going to run Cuckoo as a non-privileged user to be able to make sure that we are securely running within our sandboxed environment. So I'll do an update. Go ahead and do an update. Do a -y. So grab all of the latest packages. And then once that's complete, we will run through the rest of these commands, which will be required to get our Cuckoo instance up and running. We will be taking advantage of virtual environments. Cuckoo recommends doing that. That way we can easily, tear down a virtual environment and reinstall if we need to, if we have any misconfigurations or anything goes wrong. So I'll walk you guys through those steps as well. But just be aware, we will be working with a virtual environment. So that'll using Python to do so. All right, that looks good. So now we'll go ahead and get into installing the packages that are required to get this up and running. So again, I'll just go line by line, and I'll skip ahead so I'm not wasting too much video time. And now we've gotten to the VirtualBox installation command. So again, as I mentioned, I will be using VirtualBox for my virtualization environment. You could also use Linux's KVM, that virtualization that comes bundled with the kernel. However, I like to use VirtualBox because we can use another tool called VM Cloak to dynamically spin up VMs and tear down VMs when we're not doing any analysis, and that'll become more clear as we get into it. Go ahead and install VirtualBox with this command here. Then we're going to install tcpdump and AppArmor utils. tcpdump is probably already installed. I'm just going to include it in this command anyways, just because I'm lazy. And all right, so we got VirtualBox installed, so I'll install tcpdump and AppArmor utils. And this is important because we're going to be, in order to analyze the network traffic that is leaving and coming into the sandbox environment, we will need to use tcpdump and AppArmor utils to actually capture that traffic. And then this is kind of a side step here. If you want to create a new Cuckoo user to actually run Cuckoo with, you can do so here. I'm actually just gonna skip over. I'm just gonna run as my open secure user. But if you want to add a user that is just going to run Cuckoo, you can create a Cuckoo user with that command there. And okay, so I'm going to create a pcat group, and then I'm going to add my user to that group. So here I have Cuckoo, which I will just replace with open secure. All right, and then I'm going to change the group of the tcpdump binary to this pcat group. So my open secure user is a member of this pcat group, so he will be able to run tcpdump. Oh, and I said Cuckoo. I need to change that with open secure. All right, then we're going to run this command here, and we will verify that that command took by this git cap. So you should then see this output just below, so that looks good. Then we're going to run this disablement here, so that Cuckoo will be able to again capture the network traffic that leaves and enters our sandbox. I'm going to run this command here, even though I'm pretty sure we already did it. Yep, so that looks good. Now we're going to install M2 Crypt just using pip. So that is a Python library that is needed for us. Oh, not -y, forgot that doesn't take. Their documentation I will note their documentation does recommend this particular version of M2 Crypt. However, I was having problems with that, so I just removed the version and just said, hey, let's just grab the latest version, which it looks like is 0.38.0, and that works fine as well. So you can just avoid specifying the version number, and that's fine. Now I'm going to give the ability to my open secure user account to run VirtualBox. So I'll go ahead and set that with that command. And so now if you've created your own Cuckoo account, you can go ahead and create, you can go ahead and jump into that Cuckoo user. I'm just using the open secure user, so I'm just going to stick with that. And now we'll have a bash script here that will install our virtual environment for us. So I'll go ahead and just copy this bash script here, and I'll just throw that into opt, and I'll just call it Cuckoo setup virtual environment, and copy this guy, contents of this guy here. And this will just make it easier for you guys to be able to spin up a virtual environment a lot easier. So that looks good. And then we'll go ahead and run it with a sudo -u, and I'm going to specify the user. So I'm going to specify open secure. You could, if you created Cuckoo user, you would specify Cuckoo user. And then, oh, actually, I need to make it an executable first. Sudo chmon. Okay, and now let's go ahead and run that script. So use the open secure user and / this guy. And again, this is just creating a virtual environment wrapper for us, so that it's a lot easier to create our virtual environment and then work on our virtual environment. All right, and now that we have that done, let's reload our current bash environment with this command here. All right, that looks good. All right, and now it's time to create our virtual environment. And within this virtual environment, Cuckoo recommends running on Python 2.7. So we're going to tell this in virtual environment, hey, we're going to use Python 2.7, and then this will be the name of our virtual environment. Within the docs, I have it as just Cuckoo test, so that's fine. So we're going to create this virtual environment here, and this. All right, and so once that finishes, you should now see that we are in our virtual environment. And that should be obvious because next to the user that you're logged in with, you'll see the Cuckoo test, or whatever name you gave your virtual environment there. All right, and now let's go ahead and update our setup tools. Using pip, just in case it is outdated. Instead of upgrading the setup tools within the host OS, we're only doing it within this virtual environment. So if there's ever any problems with this, it's really easy to just tear down and start over again with a new virtual environment. All right, so now that's complete. Let's go ahead and install Cuckoo within our virtual environment here. And it's as easy as just running a pip install. Which is nice. So the installation once we kind of get our environment all set up, actually installing Cuckoo is relatively easy. And again, since we specified to create this virtual environment with Python 2.7, all of our pip commands, as you can see, are using Python 2.7 to actually install. All right, so now that we have that installed, pretty much our environment is set up and ready to go. However, what we still need to do is download our ISO for our sandboxed VM. So we're going to download a Windows 7 ISO that Cuckoo actually provides on their website, and we're going to use this ISO to, when we want to analyze some malware, we're going to kick up our VM, right? And that VM is going to have an image of Windows 7. So we're going to go ahead and do a wget, and you can do this within your virtual environment. That's fine. So we'll go ahead and grab the ISO file. It is a few gigs in size. Yeah, it's about just over 3 gigs. So this may take a little while depending on your network bandwidth. All right, so now that we got that downloaded, I'm going to create a directory that I'm going to mount this ISO to. So go ahead and create that directory. I will then change the ownership of that directory to actually my OpenSecure user. Again, this would be whatever user you're using to run Cuckoo. So I'm gonna change the ownership of that, and now we're going to mount that ISO to this directory just with that command here. And now let's get into the vmcloak install process. So what vmcloak will allow us to do is to only, because the ISO, downloading the ISO and spinning up the VM can be a long process, we want to make that quick and fast. And what vmcloak allows us to do is to take snapshots of a VM, that so we don't have to go through this whole process every time we want to kick off a sandbox interaction, right? We'll just load the snapshotted created process. So now it'll be a lot faster once we want to run a analysis. So we'll go ahead and grab these installed dependencies, these needed dependencies. They're probably already installed, although there may be a few that we missed. So we can go ahead and just make sure we have everything, so that all looks good. And now let's go ahead and install vmcloak with just a pip install as well. And all right, so now we have vmcloak installed, and this will also allow us to interact with VirtualBox within a headless environment. So again, if you have any previous experience with VirtualBox, you've probably done it through VirtualBox's GUI, but since we don't have the desktop version of Ubuntu here, we just have the server version, we of course don't have a desktop GUI. So we'll need to interact with VirtualBox via our command line here, and vmcloak also allows us to do that. So this command here, we're going to be able, we're creating a virtual network that our sandbox environment will run within. So we're going to do that with this command here, and you should see some output here, and then you should see interface was successfully created. If you're seeing any errors, just make sure that your user is allowed to interact with VirtualBox. And now we're going to set up the specs around our VM that we're going to be running our malware within. So here you can see a few tags. So CPU, so how many CPUs do we want to give this VM? Again, this is borrowing resources from your host VM. So on this guy, I have a 4-core CPU. I only have 2 gigs of RAM. So I don't have much available. If you are looking to do this in a production environment and to give you scalability, you'll of course want to deploy this on a beefier box. But just for this demo, and I am running out of resources to dedicate to my lab environment, so I as well need to do some upgrades as well. So but we're going to be initializing this VM. We are going to use our Windows 64 base ISO that we downloaded, and we are going to give it, I'm going to give it 2 CPUs, and since I only have 2 gigs of RAM total, I'm just going to give it 1 gig of RAM. So I'm going to change that on my end here. I'm going to cut this in half on my end to just 1024 and hit enter. And this will probably take a while depending on how beefy your box is. Mine is not very big, so this is going to take a while on my end, so I'll skip ahead. While you're waiting on this, check out some other videos. All right, and once that completes, you should see similar output, and we'll see here that vmcloak has added this image to our repository. So that looks good. Now we are going to clone this image so that we'll be able to create a snapshot out of it. So we'll run that with vmcloak clone. This should run a little faster than the previous command that may have taken a while. And all right, so now that we have that done, we have our VM clone now. Now it's time to install the software that we want to be bundled with our Windows image. So if we run this command here, this vmcloak list steps, this will list out all of the software that we can actually bundle with our Windows ISO, which is really cool. We have Internet Explorer version 11, Flash, Firefox, Edge, Chrome, .NET. There's a ton of Adobe. You can install Office as well. There's a ton of software that we can bring into our Windows image, which is really nice because different malware will try to exploit different software, and so we would like to bundle it with as much as possible so we get a good kind of representation of a legitimate system on our network. But in this demo, I'm just going to install Internet Explorer 11, just because the more you install, of course, the longer it'll take. So I'll just bundle it with IE 11. And if you want to add more software, you would just do a space IE 11. So I would run the same. I'd run that same command. I would just do space like Java 7 space Adobe and etc. for however many packages you want to, for whatever software you want to bring in as well. So we got this running. This will probably take a while too, so I will see you guys in a sec. And all right, so now that that has finished, it is now time to take snapshots of our Windows box so that we don't have to go through this whole vmcloak process again. If you guys are following this demo, I'm sure some of these commands took a while to run. So we can take advantage of these snapshots to where we don't have to install the Windows ISO, we don't have to add software to the ISO that is built. We can take snapshots of them that will allow us to then just save a version of this, and then we just, when we want to do an analysis, Cuckoo runs this ISO for us, which is nice. So here we're going to do a vmcloak snapshot. I'm going to do a count of 1. So this will create just one VM that we can use. So if you have, again, this box isn't beefy by any means, so I am limited on resources, but if you are in a production environment and you want to maybe run multiple analysis at once on different VMs, you would just increase this count. And then this is the name of the clone that we created. So if you change the name here, make sure you reflect that within this command as well. And then we're giving it just an internal IP address that it will be given. And if you increase this count to like 2, you don't have to list out multiple IP addresses. It'll give the first one 192.168.56.101, and the second one will be a .102. So it'll increment that for you. So this process should be a little faster. And all right, so that's finished. Now we can use this command here to list out our VMs that we have created. So this will just list out the one that I have. So as you can see, it's created this VM here. And if you increase this count here to create multiple VMs, you should see them all listed here. And how it works, it of course here assigns the IP address for us that will be used for the internal use. And it also gives it this name, and it just adds like a 1 or a 2 or a 3 to this name of the VM as well. And well, you'll see why that'll be of importance here in a sec. But now we are pretty much ready to now start to run Cuckoo. What I am first going to do though is create these IP table rules that will allow our VMs that is running the analysis to access the internet. So they will actually take advantage of the interface that we have configured on this box to reach out to the internet to do further analysis. Like if malware is trying to reach out to a command and control server, we'll be able to actually see that happen, because that traffic will be able to get out to that server. So if we log in here, I'll just open a new terminal for it. These commands here. And so this one, you'll just copy and paste exactly. If also another rule of importance here, if you change, so here I'm specifying the VBox net 0, which we created up here. So if you gave your VirtualBox network interface a different name, you would just need to make sure that they match here. So I'll go ahead and run that command, and like that. That looks good. And then I'll do an if config real quick. And for this command, you will replace the string of characters here with your interface name. So by default, I think most Ubuntu boxes label the first interface as ENS160. So I will copy this and then replace where we have that, and then replace the your interface name with the name of the interface. So again, that'll reflect what we see here, ENS160. So that looks good. And if you want to make these persistent across like a reboot, you could always edit the sysctl.conf. So you could add those same commands. You would strip out the sudo sysctl-w and just paste them in within here. And actually, you know what? We'll just go ahead and do that. So I would do that. And then that way these settings are persistent. So if the system reboots, it will apply these settings once it's done rebooting automatically for you. So you won't have to run those commands again. That's nice. And then we'll have some IP table rules created. So, and this will be what's responsible for, taking the traffic that's running within our VM, within our sandbox VM, and getting it out to the internet. So again, where we have your interface name, we'll replace with ENS160. I'll do these other commands here. And then here we're saying let's forward all the traffic that is from this network. So if you change the internal network that you're going to be using within this command here, you just need to make sure that you have reflected that network here within this command as well. But I haven't changed those, so those will be the same. And all right, if we do a sudo IP tables-vnl, we should now see our rules listed here that we just created. So that looks good. All right, and now let's go ahead and start to get started with Cuckoo. And all right, so we are now ready to start Cuckoo. So open another terminal here, just because there will be a series of commands that we'll need to run here to make sure this is working as expected. So I'm going to jump back into my virtual environment on these two other windows here. So if you lose access to your virtual environment or get disconnected for whatever reason, you can just use the command work on and then the name of the virtual environment. So in our case, that was Cuckoo test. And you see now that I have been plopped into our virtual environment here. So I'll do the same thing here. Work on Cuckoo test and same thing. All right, so now let's go ahead and do a Cuckoo Initialize. So this will create the config folders that we need and just initialize the start of Cuckoo. So I'll go ahead and do a Cuckoo init, and we should see this fire up here. So here you see it has created a Cuckoo directory within our current virtual environment working directory. If you want, you can also specify, you can also configure a different working directory that you want Cuckoo to have to live and have its configuration files and everything. But by default, it'll just spin up a directory within your virtual environment here. So if I do a ls, so if I cd into home, open secure, and A to expose hidden directories, we will see our Cuckoo guy here. And we can go ahead and navigate to that directory, and now we see Cuckoo's directory and configurations and rules and all that good stuff. Okay, so we got that, and now let's run a Cuckoo community. And what this will do is this will download the latest rule files and everything that enable Cuckoo to detect and alert on malware. So here we can see it's reaching out to GitHub, so make sure you have access out to GitHub so you can grab their latest rule set, and that has finished. All right, and now let's go ahead and configure, get Cuckoo configured to be able to connect to our VMs, connect to our routing that we want to use. This is a cool little feature because it allows you to do different routing depending on what you want to do. So we can tell our VM, like when it's doing traffic analysis, where do we want to route that traffic to? In our case, we're going to use the internet routing. However, there's a few other options you could do. So you could route through a Tor network. You could route through a VPN if you want. So it's really nice. You can kind of dynamically tell Cuckoo, hey, when you see, for this particular traffic, I want you to take this particular route. You can also do a no routing and drop routing if you want. So, but keep in mind if the malware is trying to reach out to the internet to then, maybe download another script from a command and control server, you would be blind to that. So I will just use the internet routing in this case. They have some write-ups as well on the different options that you can do. Some of them require different kind of dependencies, but they are there to explore if you want to, which is a nice little feature to do. So, whoops, let me jump back here, and okay, so I'll leave this one just for running Cuckoo. I will run this one in the side. And so what we're going to do, again, since we're not going to run Cuckoo as root, we are going to run it as our user. In this case, my user is just the open secure. So what we need to do is start the Cuckoo router. We enable the sudo flag because in order to start this, it does need sudo privileges to interact with IP tables. However, we don't want it to run as sudo, so we don't want the routing to run as root. We still want it to run as our user that we're using to run Cuckoo, to avoid running it as root, but also giving it it needs sudo privileges to be able to route correctly. So we'll tie it to our open security user here. So I'll copy this guy and paste this guy in, and if I run that, password, and we should see now starting Cuckoo router. Okay, so that looks good. And now let's go ahead now and make our configuration tweaks within the Cuckoo conf file. So if we jump into Cuckoo here, I'll cd into their conf directory. And in this demo, we're going to focus on the routing.conf and the virtualbox.conf. If you went through if your virtualization software that you're using is going to be KVM, then you would just jump into that file here. So let's go ahead and jump into the virtualbox.conf. And here you'll see our machine. So this is telling Cuckoo, hey Cuckoo, when I want you to run an analysis, I want you to run on the VMs that I have cloned already. And we went through that step with all of our VM cloak commands. So what we'll need to do is to specify that within Cuckoo. And the mode we're using is a headless version of VirtualBox. We're not using the GUI version because this is a server image. So we don't have a desktop GUI. So you could make these changes manually. However, there's a little while script that we can run through that will list out your VMs and then add them for you. So if we just copy and paste that there, it will take the VMs that we created and add them to our conf file for us. So now if I open this guy back up, you see the virtual machine that we cloned, right, that we saw. And if we list it out, if we do a VM cloak list, we'll see that there as well. So we're telling Cuckoo, hey Cuckoo, I want you to use this machine. And if you have more than one VM that you've cloned, those will be added as well. So I'll go ahead and remove this Cuckoo1 so it doesn't exist anymore. That is the only problem with this Cuckoo machine command that we use here. It doesn't remove the Cuckoo1, so you'll have to do that manually, but it has added our config block for us, or it has added the machine VM for us, so that's good. And now you can see we need to remove actually this Cuckoo 1 full block. So all of these configurations below will apply to this Cuckoo 1 machine, which of course doesn't exist because we never gave it that name. So I'll remove this full block, and what that while script actually did for us was create this block here. So now this is the name of the VM that we want Cuckoo to use when it runs. It does a label, the platform is Windows, the IP address is this .101, which is what we assigned it earlier. So all this should be pre-populated for you, and that all looks good. So we'll exit and save that. So that looks good. The last thing before we kick this off is let's jump into our routing.conf. So again, depending on the route that you want to use, again, I'm going to use the internet. Again, this reflects back to what our routing options are here. So I'll find the internet block here, which is just right here, and this will be the name of the interface that is on the host VM. So in our case, that's ENS 160. So I will save that, and then actually the last thing we'll need to do is the reporting. So we're going to be, I think it's the reporting. Let me open this real quick. Let me search for Mongo. Yeah, okay, so MongoDB will be our web GUI of Cuckoo. So that if you guys followed my install commands, that was installed as one of our prereqs, like what we have here. So you should already have this installed. You just need to change the enable no to enable DS. And pending that all looks good, our router looks good. So let's now kick off Cuckoo. And to do so, we'll just run Cuckoo, and that's it. And this should start up. Then we should see some routing. You should see some output within your Cuckoo router, like what we see here as well. So if you don't see this, then your Cuckoo router is not working correctly. It may be one quick thing to troubleshoot if you don't see this is make sure that the router was started with the user that you're using to start Cuckoo as well. So you would change where I have OpenSecure here to the user that you are currently using. So make sure that that is in place, or else you'll have some problems. And here we can see that it's using VirtualBox as our machine manager, so that's good. And it has loaded our one machine, so that's good. And now it's waiting for the analysis task. And the last thing that we'll need to do here is to spin up the web UI. So I'll jump on this last one here. So I'll jump on this one here, and okay, yep, I have a session. Let me get the IP address of this. I could just put it to the local loopback, but I always like to specify it on the interface that we'll be using. So this is the IP address of your host server. So I'll go ahead and do that. And we should see that it has started. Okay, that looks good. So now we should be able to connect to this guy from our browser. So if I just copy and paste this in, good. So we are now have loaded Cuckoo's web UI, and we are now ready to run some analysis. So that looks good. And all right, so now that we're ready to go, let's go ahead and run an analysis. I'm going to use this iCar test file here. If you're not familiar with iCar, it's just a harmless text file that will be flagged by antivirus signatures. So it's a good way to test your security tools to ensure that they are detecting what they should detect. And the cool thing about Cuckoo is the cool thing about malware is it helps give security personnel a job. But the cool thing about Cuckoo is we can do text files, we can do EXEs, DLLs, we can even do zips, which is nice. So Cuckoo will unzip all the contents within the zip folder and run those as well. So I'm just going to grab their zip folder that they have, and Now that that's downloaded, we will just go ahead and upload this guy to Cuckoo. So it's as easy as just dragging and dropping it into here, and this will bring us to our next screen where we can, where we will configure our analysis. So here you can see it's already actually unzipped the contents of the folder. So we can select, if this had multiple files within it, we could individually select which ones we want to run. So I'm going to select this guy here. Again, we will now go to our network routing. So if you've enabled some of the other routing options, those will be available for you to select here. However, we've just enabled the internet one. We'll then scroll down. So we have the timeouts that you can set. There are some other few advanced options. We just went with the basic install of Cuckoo, but they also support some other features that are pretty cool, such as this Guac D one. This Guac D will actually allow you to interact with the VM as it's doing its analysis. So maybe if you want to do something manual within the VM as it's doing its analysis, that tool will enable you to do that. It is a few other dependencies, so you can link to their documentation that they have here to get that installed. Maybe I'll make that a future video as well, just because it is something that's cool and nice to have. But it's just a little out of scope of this one. I just want to get you guys kind of up and running and familiar with Cuckoo first. So that looks good. And then down here on our machines, you can leave it at default. If you have more than one VM that you took a snapshot of, those should all be listed here. So you could run it on an individual machine basis, or this default one will just select the one that is available to run an analysis on. And that's it. So you make your few option changes. We'll click Analyze. And here, if we go back into Cuckoo here, we should see it start to spin up. And sure enough, it does. So starting analysis of the zip archive. We see that his starting analysis. I've done a few analysis already, so this is number 4. For you guys, it'll be your first one. You'll see that it picks up the ID of the VM that it's going to run this on, and then it knows its IP address of our 192.168.56.101, and that is the virtual network that's running within VirtualBox. And here we see that it has started to kick off the analysis and is running. This iCar file within our Windows VM sandboxed environment that is currently running in. You can also, it'll queue up analysis as well. So if you want to start another analysis immediately, you can go ahead and do so, and it'll queue it up. Or if you have more than one VMs, it'll select the next available VM to run this analysis on. So you can do multiple analysis all at once, which is nice as well. So we'll wait for this to finish, and then we should see some results. And here on our dashboard, you also see that it is running one job. And once this is finished, it will generate a report for us. You can see all of the details around, what this file was doing, what signatures did it flag on, what network connections were made, and so on. All right, and now that that has finished, if we go into recent here, we will see our report, and you can select either of these guys. I'll just select the date here. And here, Cuckoo now generates a nice report for us to be able to see exactly what was going on. So here we see the score, so it's given it a 3 out of 2 out of 10. So it has detected malicious behavior. And again, we just gave it this iCar test file. So it is detecting on what we expected it to test on. And then you'll be able to look at all these signatures. So by default, it looks like Internet Explorer, when it launches, is trying to grab various certs and data from Microsoft and Bing. So we can also, on the left-hand side here, you'll also see these other kind of categories that we can go into. So like, what's the behavior that's being done? So here you can see it's using the Internet Explorer executable to actually launch this, which granted, this is just a text file, so it's not going to be doing anything browser related, but we can see all of these details here. We can look at dropped files and see what files the malware may have dropped onto our box and what signatures they may have matched. We can look at the process memory to get a dump of our processes that are running within memory here. So we're getting all this information from our analysis, which is really useful, and you can really use this to now make better decisions on, okay, what are our next steps. And we can easily tell if something is malicious, and not only if it's only malicious, but what exactly is it doing? What exactly is it doing to maybe escalate privileges, to maybe start to infect other hosts within the network? We really get a good idea on what all is being done. So it's really nice. And it's a little bit more technically complex with the install process, but hopefully this demo will allow you guys to get it spun up and going within your own environments, and you can start to get your hands on it there as well. But I think this wraps it up for today's video. I think I'm going to do some future ones on this, like including we can bake Suricata into this as well. So TCP dump will capture the PCAP files, and Suricata has the ability to analyze PCAP files. So as part of the analysis, we will feed Suricata our PCAP file and say, okay, are there any Suricata matches on this as well? So we can analyze our network traffic to see what exactly would have been is being flagged there, which is really nice. So I appreciate you guys hanging out with me, and I will see you in the next one.